my name is Rich Howard, owner of Architectural Builders Supply, and this video is to attempt to replicate a door pull that a client sent to us. I saw the photos and I immediately realized, well, this is going to be 1960s, would be my best guess in terms of a vintage. Okay, now unfortunately, here's our piece. We got some really good parts up in here, but unfortunately they're not all good. Some of them are going to absolutely require some reworking. However, some of that reworking I expect to be fairly minor. Yeah, pretty minor. Yeah, like here, we're going to have 110 thousandths to take off there. So, yeah, I'm going to, like here, these pieces are really good inside of here. I'm going to cut those off. I'm going to take a look at them. And, you know, I'm going to yield out of this what's good. And then we're going to put elbow grease into those parts that are less good. So let's get a little tool. I've got a Dremel tool here, I've got a die grinder, I've got a hacksaw. Let me grab a tool and let's get a part off, a couple of them off that we're going to use, and let's take a closer look at it. So let's do it. Actually, before we go and liberate a part, I do want to touch base on down in here, this part, and possibly this part, and absolutely this part. Those were not part of the nesting because they did not meet the requirements of minimum, of the clearance requirements. I manually inserted them. What I manually also had to do was change where I was tabbing because I was using basically a common wall, as you can see here. Now, having said that about this common wall, that amount of aluminum is tiny. And I'm thinking that I'll be able to use a common wall, whatever that dimension is. I think I took it down to 3/16. I think I'll be able to use a lot less, so I'm going to yield more parts out of this. The point is at the very end, I realized, well, if I moved my tabs, I had some of the aluminum left over that I said, boy, that's a big chunk of aluminum. And when you take a vector and you try to place it in there to see if the software made a mistake, you'll find that you cannot stick any more in there and maintain the margin that the software was told. So I manually placed 3 or 4 of them in there. I moved my tabs. I sacrificed that clearance dimension because I, at that point, had believed reducing it would be okay, which it turned out to be okay. All in here. This is all a perfect example of those clearance issues, of those clearance values. So all of this is completely rock solid. The issue is aluminum is expensive. This is a $500 piece of aluminum that we only got about 58 pieces out of. Well, let's just say 50. $10 each just for material cost, plus the machining time, plus the I mean, how much is a pull handle going to cost someone? $400? It might. It just might. And the mounting post is a lot of the work. The handle itself, yeah, it was work. There was tool pathing, but running that type of tool path is nothing I'm going to be needing to mother hen over, you know, within earshot. And that's just going to be bars and bars and bars of material the entire table. Okay, so let's take a couple pieces off and let's go from there. All right, so what we're going to do now is we're going to take our Dremel tool and cut a couple of those mounting posts off. Take a look and see what we can see. Let's do that now. I'm going to flip the piece over. We're going to start out here where I know I got a couple of really good pieces. Let's take a look in here. Let's see what we've got. It's not awful. little bit of filing, which we'll do next. Let's get the next mounting tab off. We'll look at both of them. And we're going to tweak these tabs as we move forward because I don't like how much I'm having to remove. The problem is we're creating a lot of aluminum dust. Let's come over here and take a little closer look at what we've achieved. Yeah. Yes. So that's going to be to the face of the door. So all I need to do is dress that off, dress that off.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
So, yeah, we've got to dress that tab, the remainder of that, the artifact of that tab. Here it's a lot easier. So let's take and file these, and you know what's really interesting is I'm getting a different pattern here, and I think the deal is I used an SGS end mill over here and then an ONS root at the bottom. Interesting. All right, let's walk back over to where we were. Let's file a little bit because I'd like to send the client a update, which is translation. Here's what they look like. Let me put this back away. And I just so happen to have in my back pocket a file. So these tabs, these mounting posts, these are ready for prime time. The only thing I would do next is I would throw these into the parts tumbler for an amount of time that is yet to be determined. So here's what this is going to look like. That's nice. That's real nice. That's going to work, baby doll. That's going to work. This little box right here will serve as our backdrop, our holder. Huh? Huh? Yes. Yes, 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 yes. Okay, so what remains? What remains? I have to drill a hole through this backside so that the client can get the mounting bolt into there. I then have to drill and countersink into this side a hole for the bolt. I then have to drill and tap into the back of the pull handle so I can get that attached. This is what I have to do next. While we're here with these parts, let's grab a couple of the bolts and let's see if it's going to actually work. Very good. So I've got a 1/4 28 by half. I think I've got the wrong bolts here. I think I want is a 1/4 28 by 3/4. So it's going to actually look like this. That bolt's going to go through there and stick into the handle. That might be adequate. That might be plenty of penetration. I mean, it's only 1/2 inch. The issue is what I really need is a 5/8, and I'll see if I can get a 1/4 28 National Fine in a 5/8 length. I would prefer that because 3/4 is gonna be too much. It's just the bottom line. Now, this 1/4 28 by 3/4, clearly what I have planned for there is to be able to go through the back side of the mounting post here to go to the door. So that little button head screw there is going to go just like that. I like that. And a new installation is going to see us using a riv nut, a 1/4 28 riv nut. And I had relieved, if you recall, the back side of the mounting post for the head of that riv nut to sit like that. I think we're in a good spot here. What I'm going to have to figure out how to do, though, is in production, to make a fixture to be able to drill these reliably. And I've been thinking about how to do that. I was thinking what I would do is take this same vector and cut a 1-inch thick piece of polycarbonate. That would give me a block that I could slide this in, put that block into the drill press, and voila, right down. Obviously that block could also do it this way as well. So that's probably going to be what I would consider doing long term. I'm probably going to freehand it to do this. Well, not really freehand it, but that's where we are. So hey, listen, where we're going to pick up next is going to be literally getting set up to drill and tap these holes. That's going to be tomorrow. It's 3:30 where I am, and I am good for the day at this point. So let's pick up tomorrow. Okay, here we are in the next day in the shop, and we're going to get those holes drilled. So this is the first time I'm doing this, so what I'm thinking I'm going to be doing is just trying to figure out what our process and procedure is going to be. At this point, I'm not really going to be analyzing how I can improve the steps of getting these holes drilled and tapped. This is just fumbling through the process. And obviously the point of making an entire sheet of this material is to obviously provide these to the public. And as I had mentioned, it turns out these pull handles are probably more common than I thought. So the logic is if you build it, they will come. So I'm going to go about setting up the shop. I'll let the camera run. This is probably going to be a lot of time lapse what's happening here. Thanks.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
The way that I've got this logic set is, my approach with this material is when a client places an order, we're going to send them everything that I think that they could possibly need, in the sense of, you're going to get the bolts. For mounting the mounting posts to the door, we're going to send you this really neato Toledo button head bolt. And that's going to set right inside of there. Okay, so it's going to be great. The question is how to get that installed. Well, we've got this really cool short leg Allen wrench here, so we're going to be including that with the installation so that a customer can get the riv nut attached to what we're assuming is the aluminum door. If it's a wood door, I'm going to have to come up with some other fasteners, but I know that this is an aluminum installation, so I'm not worried about expanding the product line just yet. So when this is going to be installed, like so, the client's going to be able to get this tiny little wrench right inside of there and be able to turn that. So that's going to be the logic. So riv nuts are going to be for a steel door installation, a riv nut, and I'll show you the riv nuts. Basically, it's a riv nut, R-I-V-N-U-T. You're going to drill a hole in the aluminum hollow metal door, the thin wall material. And you use a tool by which that you're going to tighten the riv nut, and the riv nut's going to collapse over the thickness of the door itself. So an aluminum storefront, it's 1/8 of an inch. So, and that's very common. Surface concealed, they call it. There are other ways to do it. A customer could drill and tap a hole in the door and then have a cone head bolt. This sort of mounting post would not allow that because this is not thick enough to be able to then cross-bore a drill in the edge of it for a set screw. That's never going to happen. Not unless I really change the design of this, and I actually think that I could, because Elms, E-L-M-E-S, they're a Japanese manufacturer. I'm pretty sure their mounting posts are shaped in that way. Obviously, what I'm really looking to do is to minimize how much work has to be done after the fact on my white whale here, my little, it is my white whale, on my growing post-processing mobile cart that seems to get more complicated with every passing week. And one of the gentlemen that I have come here and help me work on a part-time basis, he kind of looks at me and says, you know, what's this cart going to cost you by the time you're done? So I'm going to drill this hole. That's going to be low-hanging fruit. I'm going to get it placed in the center. Let me go grab a riv nut. And again, I've created the relief on the back of the post for the riv nut to be able to sit really flat inside of there. And basically what you do is you drill a hole, and the riv nut has splines on the side. I don't know what size hole this is yet, but I will. You drill that hole, you push the riv nut in, then you use a tool by which you're going to run a bolt into it, and then a female receiver that the bolt must go through, so that when you tighten that female receiver, it will force the riv nut to collapse over the wall thickness, and that's how this is going to be installed. It's 1/4-28, not 1/4-20. I really want fine thread when possible. We're dealing with thin wall material, and I want to be able to use a fine thread in this regard. I would, of course, be suggesting maybe I can find online, if I'm going to supply these pull handles with all the parts that you're going to need to walk up. The only thing you're going to need to bring to the party is a power drill, possibly, a crescent wrench, possibly. I'm thinking about finding small packets of thread lock. What would you use thread lock for, in fact? Well, I suppose you might dip some on the bolt going into the riv nut, but when I drill and tap the back of the pull handle itself, I'm going to be dipping thread lock into that. So we're gonna start with just drilling this easy hole. My goal is to get that position right in the center there. So I'm going to continue on with the process. I do have to figure out what size hole I'm going to need for this. Come up with some drill bits here that we'll be able to use. What I don't see I have laying about is a countersink. This could be good. 5/16 for the finishing hole. Probably not going to be what I would want to use in production, but going to be fine for this. All right. Got some drill bits. Let's get our drill press, and let's keep moving forward. So at this point, I am just going to use the drill press to drill through this. I'll get a couple of blocks of wood to hold this in my little vise, and that's what my approach is going to be. So, I think we'll set that there, and we'll just see what we can see with all of this. I haven't used this drill press in a little while. So we've got our part set up here, and I've drilled the first hole after getting the piece dialed in. I drilled maybe 1/8 of an inch hole just to get that set exactly where I like it. And I'm going to drill the 5/16 hole, and seems to be working out just fine. Let's drill this second hole. If you're drilling brass or aluminum, get bits that are meant for that. And I find with aluminum, you got to lean into it. And once you get a critical mass there, you're starting to cut. The limit of the travel is going to be really important when I'm drilling the back side of the pull handle, so I don't drill through it, obviously. I'm happy with that. Let's turn the tool off and let's take a look and see what that all looks like. Okay, that hole is drilled. Got some artifacts on the back of that. You know, tumbling is probably going to make that go away because these parts would be tumbled. At this stage of the game, I'm going to hit it with my trusty file. Just want to take that off enough. Oh yeah. Yeah, we're good now. The hole's not perfect, but it's probably good enough. Here's the test. Let's drop that bolt in there and make sure it sits. Oh yeah, that dog will hunt. Yeah, not perfect, but perfect enough. Boom. Put the riv nut onto the back of this bad boy, and we're in good shape. All right, let's drill the hole for the back of this, the second mounting post. And I'm going to change the drill bit. And what's nice is I've got the same 1/4-28, but we'll have a different drill bit when we're drilling for the tapping component of this. Let's put the tiny drill bit back in there. Let's do that.
Again, thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.